All right, guys, welcome to Unit 6. This is going to be going over equipment and accessories, so shouldn't be too overwhelming with content. Just to go over some of the stuff we talked about in the previous unit. All right, we should now know what the three modes of metal transfer are, right? We've got that spray transfer, which is the OG. We've got the short circuit, and we've got the globular. Okay, and you should know which one of these in order, or let me rephrase that. You should know the order of these, which process is the coldest to the hottest. All right, which mode is capable of doing root passes on pipe? Only one of those three modes is going to be good for root passes. Which mode is limited to 18% CO2 in the gas blend? And then what mode of metal transfer would you choose to weld on 3/4 inch thick plate? All right, there's only really one correct answer for that. Okay, so for this unit, we're going to be going over GMAW equipment, power sources, dive into a little more. We've probably covered this already a couple times, the constant current and the constant voltage power sources, what their differences are, and what in what scenarios we would use either one. Describe the selection of proper torch for GMAW. We'll break down the parts of the GMAW system, and then out in lab, we won't go over how to change the liner, but we will do an exercise if we haven't done it already, going out and simulating swapping your wires, and we'll break down the drive roll system and all that stuff because there is a quiz that you need to be able to identify not just the parts of the GMAW gun or torch, but also the wire drive system. And then I think maybe also a couple regulators, flow meters. Okay, so power sources. We got light to medium duty power sources. What we use here in the shop would be considered a medium duty, the 300Cs. The range and current capacity is from 135 to 350. So the machines we have here, those 300Cs, that's right in that range. So those are a medium duty power source. Very versatile, but going to be limited on the super heavy stuff. So this is intended for limited sheet metal applications. Obviously, we can still do structural. We just can't go, super crazy with it. Okay, so constant current. We've probably gone over this in lecture already. So hopefully you guys are getting a grasp of the difference between constant current, constant voltage. All right, in a constant current machine, the CTWD determines the arc length. Okay, so constant current, that would be our SMAW welding or our GTAW welding. All right, you are controlling the arc length. When you lift off, increases the arc length, you get closer, decreases the arc length, and that changes the voltage. Okay, so as the CTWD increases, that contact tip to work distance, the arc length increases. As the CTWD decreases, the arc length decreases. You got to remember, the more wire you've got sticking out the end of your MIG gun, the more resistance you're giving the current. So this presented a problem for semi-automatic welding because it is difficult to maintain the same CTWD, right? So when you're doing TIG welding, SMAW welding, you can keep a fairly consistent arc length. But when you've got a machine feeding that wire, it's a little more challenging keeping that arc length, that CTWD, constant. Okay, so they needed to go from constant current, where like our SMAW welders keep that current constant even if you lift your arc, that electrode, a little higher off the plate. Okay, keeps your amperage the same. So they needed something that could regulate that arc length as the wire's feeding. Okay, so this is just a visual representation of the voltage and current, kind of like that current density we've gone over in class already, probably a couple times at this point. All right, so when we're using a wire-fed system, we need constant voltage. This provides specific arc voltage for pre-selected wire feed speed. So on your machines, when we're in GMAW mode, now you have a voltage setting. All right, when we're SMAW welding, all we had was amperage. Our voltage is controlled by our arc length. Now we have a machine that is feeding that wire rapidly, okay? And it's very difficult to keep any amount of arc length. So we tell the machine with that voltage setting the arc length we want, okay? So when you set your machine to 20 volts, that's going to set your arc length to a certain dimension, all right? And going higher or lower is going to increase the size, the arc length, or decrease, make it shorter. Okay, so that voltage control on the machine now is your voltage, your arc length control. All right, or at least part of it. So again, as the CTWD increases, that contact tip to work distance, there is a decrease in the welding current because you're adding resistance. As the CTWD decreases, there is an increase in the welding current, less resistance. So just again, the longer that wire is sticking beyond your contact tip, the more resistance you're putting into that circuit. So it's going to make it colder. It's going to give you less current. In either scenario, the voltage remains the same and the arc length remains the same. Okay, so now versus you manually changing it with your TIG torch or your SMAW electrode, the machine is keeping that arc length the same depending on your voltage setting. Okay, so that voltage setting when you're in GMAW mode is your arc length control. Okay, so inductance, this is a setting in the machine. All right, power sources designed for GMAW require a feature for providing inductance, sometimes also known as pinch. I'm sure some brands call it some form of like arc control or something like that. It's all the same thing. The technical term is inductance. All right, so this is necessary for when we're short-circuiting transfer and low wire feed speed globular transfer. We don't do globular here though. Hardly anybody does at this point, but you need this for short circuiting. This provides control of the rate of rise of short circuit current. Okay, this has a heavy influence on the amount of spatter generated. Basically, this is just the amount of time that the arc is on. Okay, because remember, when you're short circuiting, your wire, your electrode is coming down and touching and shorting out. So there's a moment where the arc is off when it shorts out for that moment. Okay, the inductance setting can increase or decrease the amount of time the arc is on before it goes and boop makes contact. All right. So when you increase the inductance, all right, the amount of time that the arc is on is extended. So the transferred metal droplet size changes, and this can increase puddle fluidity. All right, remember puddle fluidity is just kind of how wet it is, how easily it kind of spreads out to the toes. This results in a bead that is a little flatter, a little more smooth, and again, that toe wetting. Toe wetting. If you're getting a real tall, humpy weld, you want to increase that voltage, increase your inductance, and that will help wet out the toes and get that fusion at the toes instead of it being really tall or cold. Okay, so most machines now use inverters, right? We've probably gone over this a little bit in the SMAW unit, but all our machines here are inverter style. They're smaller, lighter due to the IGBT, insulated gate bipolar transistors. All right, this is just, again, like the analogy is going from a transformer to an inverter. A transformer is more mechanical. It's metal blocks, magnets, and windings and coils that are just sending current through in different directions. And an inverter is basically looks like a motherboard. It looks like a computer. Okay, so just think about this as computer parts. Okay, so inverters are much more compact. They have advanced welding software that provides more control over the arc and waveforms. This is how we get to like pulses and all the whole library of different pulses, pulse on pulse, rapid X, rapid arc, all sorts of random stuff. Okay, and that's the power wave stuff that I think we may have talked about already, maybe, where we can go into the machine and get real fancy with the waveform, with the frequency, all that kind of stuff. That would not be possible without inverters. And then this also gives us access to AC GMAW and all other processes in a small compact machine. So inverter technology really blew up the GMAW sector. Lincoln Propaganda. This is actually pretty much the exact same machine that we have over at the main campus. So when you go over there for a 2B, this is the power source you'll be using. All right, looks just like this, and we do have the advanced module. The only other thing you'll see over at the main campus is one more item beneath that, and that's the TIG torch cooler. So it's a water cooler system. And then above it, you will have a dual wire feeder system with two different types of wire on either side. So wire drives and accessories. Obviously, we should have gone over this in the electrode unit. We have solid wire, which is what we use, solid wire or metal cord electrodes. That's more like a flex cord electrode. Okay, so there's different types of wire. Uh, so the wire drive system is meant to provide precise wire feed speed. So you might have to swap out your drive rolls, because remember the drive rolls, if we have not gone out and done this assignment yet where we broke all this down, they have either a range or a specific size for those drive rolls. So when you're swapping out wire, whether it's size or type, right, going from a solid wire to a flux cord wire or a metal cord wire, you may have to change out not just your drive rolls, but your liner, your contact tip. You may even need to change out your the gun itself, depending on the amperage range. Okay, so most drive roll systems provide a magnet motor for fast starting and stopping. That way, there's no like slowing down when you let off the trigger. It's an instant immediate stop and an instant immediate start when you pull that trigger. Okay, and we have two different styles: 2 drive roll, 4 drive roll. Okay. Um, they both feed wire. Okay. They do the same thing. I would say the 2 drive roll system is a little more common in compact systems like what we have, where the wire is inside the machine, and then dedicated wire feeders that are external to the machine typically have 4 drive rolls. All right. Both systems can come with a like your gas purge and your cold feed switch. Some of these might come with a light inside, some might come with a heater inside for either cold or wet climates to keep the wire dry inside. Um, this right here is also, you see this brass bushing? That is where you have the current coming in. Okay, so when you've got these panels open, make sure you're not touching these. The machine should be off, but if ever you have to, I don't know what situation you would be in, but if you have to have this open with the machine on, avoid touching these brass components, because those will be electrically live if you pull that trigger. Okay, and here's a breakdown of all the parts. All right, we've got 2-step and 4-step trigger mode. We should have gone over that. Just remember 2-step mode, you pull that trigger, it's on, you let go of the trigger, it's off. That's 2 steps. 4-step is you pull the trigger and you let go, and now it's on, and then you pull the trigger and let go, and now it's off. So there were 4 steps. Okay. And that symbol right here, it's going to be an arrow with an arrow up and an arrow down, and then 4-step would be that same arrow going to the right with 2 arrows up and 2 arrows down. Then you've got your cold feed and gas purge switch right here. Your tension adjustment chart. This is going to tell you how much tension you need on the wire drive. Okay, so depending on the wire, you want different tensions. So pay attention to that chart if you're ever swapping wires. Just make sure you're set to where it should be. You have an internal light. Again, some of these are optional. You won't see all of these on all machines. And internal light, internal heater switch, which we already talked about. G right here, this is the spindle tension. And if we went over this out in lab, you heard my spiel about not messing with this. Okay, when you're swapping the wire, you do not need to adjust that. All right, that just allows the spool of wire to spin more or less freely. Okay, so leave that spindle tensioner alone. Then you've got your wire guide plate. That is removable. That's what the wire slides through. There's a groove in there. The size, the diameter of the wire as it's pinched between the 2 drive rolls. Okay. Then you have your thumb screw right here. This is what, when you put the MEL end of the GMAW gun in there, that's what holds the gun in place. And then your gun bushing. Okay. Again, that's your gas line. That's also, this block right here is where power's coming in. So that block is where your gas and your current transfer into the gun. Okay, we also have specialty guns. So this is a spool gun. So this is like a compact alternative to a push-pull gun, which we'll go over in a little. A spool gun is meant for aluminum. Because aluminum has such a soft wire, you cannot run that wire through, a 10, 15-foot liner all the way from the machine without getting kinks. So one option is to do a spool gun, where you have a small spool of wire right here attached to the gun. and so it's kept taut the entire time because this is just solid instead of having a flexible liner. Okay, this is a pretty good if you're doing hobby aluminum stuff, you know, working on your boat trailer, things like that, or maybe your livestock trailer. This is pretty good for that. Not so much for high production. Um, uh, they get a little finicky. They usually have a much lighter duty cycle. They're just meant for lightweight kind of stuff. All right, that's a spool gun. Uh, so again, that aluminum wire is softer than steel, and it's more difficult to feed. And we're usually using smaller diameter wire. Um, we use 035 here for our mild steel, which is pretty small. Usually aluminum's a little thicker than the mild steel stuff because once you guys get to the aluminum TIG, you'll realize what I mean when I say this, but aluminum likes to eat. Okay, so for higher production stuff, we would want to use a push-pull gun. Okay, so this is your alternative. This is what you're going to see for more high production aluminum welding. You can see inside the gun itself, we have a drive roll system right here. So you put the aluminum wire in the wire feeder, and as that feeds it through the liner, this is pulling it at the same time. So it keeps that wire nice and taut inside the liner, keeps it from kinking. So we don't have to have that spool right here up on us. So it saves a little bit of weight. They're still pretty heavy compared to a normal GMAW gun just because of the drive roll system up here, but they work way better. They're a lot more efficient. For really big, heavy applications, you can get these water cooled as well. So these are meant for more medium, heavy duty applications of aluminum welding. And again, compared to the push pull guns, these just weld. It's so much nicer when you have a push pull gun. So obviously GMAW requires gas, so we need regulators. We've gone over this quite a bit from the oxy-fuel unit, so we'll kind of blow through these briefly. So we should be familiar with what a regulator is, but now we have flow meters, okay? A flow meter, those are the meters inside the boost, which I'm sure we've gone over multiple times at this point, all right? Sometimes we have them manifold mounted, sometimes they're mounted right on the cylinder. It just depends on the application. And this gives us a rate of flow for shielding gas exiting the cylinder. Okay, so in the manifold room, we've got the cylinders and the regulators. Those flow regulated past that regulator into the booths, and now we're just measuring it, the flow, right? CFH. Okay, so just think of that versus PSI. It's just a different unit of measurement. Okay, so this is what you're seeing on the oxy-fuel systems. This is what you would see if we had a portable unit with a mixed gas cylinder attached to the back of it. This is your regulator, and it's going to read what's in the cylinder, right? That's just your full empty gauge, and then what's leaving the cylinder in PSI. In the booths, we have our flow meters. So you would set this to like 20, 25 PSI, and that would come in to here, and then you would set the flow with your little knob, and that would reduce it even more. So we're getting low flow out of here, which is why we're using the CFH instead of the PSI. All right, so parts of a standard regulator, we should be pretty familiar with this from the oxy-fuel unit. This is pretty much the same. You'll notice most regulators, whether they have one or two gauges on them, somewhere on there, it's going to tell you what kind of gas this is for. Okay, so it'll say inert gases, it'll say oxygen, it'll say acetylene. Sometimes it'll say mixed, but on that regulator, sometimes it's on the back side of it. It will tell you what that is meant for. Okay. So flow meters a little different than regulators. This is a cutaway, so you can kind of see some of the internals. This is what we call the flow tube, and this is how we're measuring the flow coming out. As you open this knob, the adjusting knob, you'll see a little ball inside of there. Rise up as you increase and come down as you decrease, and that's how we set the CFH. Okay, so take a good look at this because there will be a quiz where you got to identify these parts. So torches, GMAW torches, the GMAW gun. So all accessories, remember we've talked about this before in the SMAW unit, machines and accessories, equipment in the welding industry are typically rated on their amperage, all right? And you can see that right here, level of current required by the welding application is what you're going to need to consider when you're thinking about your torch. Other things to consider though, right? the type of welding you're going to be doing. Semi-automatic, that's going to be what we do. You pull the trigger, it feeds for you, you let go of the trigger, it stops. It's semi-automatic. And then a hard automation or robotic automation. So they're going to be a little different if you're plugging this into a computer. The type of shielding gas selected, you might need specialty liners if you're doing some crazy material and you need some specialty gases. The duty cycle of the torch. So everything's got a duty cycle. Remember that is that 10-minute interval that something can be used at maximum capacity. So equipment has duty cycles as well. And then preference of air-cooled or water-cooled torches. So air-cooled torches typically have a duty cycle of around 60%. Water-cooled torches, 100%. So you can run a water-cooled torch all day until something breaks. Okay. And here's a breakout of the GMAW gun. This is again a cutaway, so you can see the internals. Your cable insulation right here. So that's the black cable you see coming out of the torch. And then inside is all the braided copper power cables. You've got your trigger leads that go to the trigger. Your cable to conductor tube connection. Okay, so this is like a threaded mate where all the cables come in and transfer power. When you pull that trigger, right, lets it pass. This is just like a gateway. Your gun housing, that's just the plastic housing. Your hanger, you may or may not have one of these still on your gun. And this is called the conductor tube. And then you have, we should know all these parts right here by heart at this point. Your gas nozzle, your insulator, your diffuser, and your contact tip. Again, there will be an ID quiz on this, so take note of those. Okay, so duty cycle rating, again, this relates to the amount of current that you're going to be running through that. Air-cooled torches are rated around 60% duty cycle for specific current. So when you go in and you're looking for a GMAW gun, remember they'll have a number on it like 150 or 250 or 350. That's telling you the maximum amount of amperage you can run through that gun, that liner, or everything in there is about 350 amps. So at 350 amps, you would only be able to weld for 6 minutes out of a 10-minute window. Okay. So water-cooled torches are rated at 100%. They don't have to worry about cooling down. You've got that water cycling through just like a TIG torch, a water-cooled TIG torch. So you have 100% duty cycle. This greatly increases the life of the consumables, even things like your diffuser and your contact tip. A lot of times when you guys look at your contact tip, they'll be really gray, and that's from the amount of heat that those things are handling. So you would even be able to extend the life of those contact tips a little bit with all that heat reduction. And then operator appeal reduces the heat transferred to the GMAW torch handle. So you guys may not get that here in class unless you're really going at it, but out in industry, when you're welding all day, those torches get warm, especially in the warmer months. So a water-cooled torch is also a comfort. All right, so that wraps up this. We'll see you in the last unit, Unit 7.